Okay, we're back for part 2 of the VFD lecture. We covered a lot of material in the first one, from the introduction to the three sections of the VFD, the volts-hertz ratio and all the calculations, and and also the algebraic formulas to demonstrate how operating outside that volts-hertz ratio impacts the torque. Okay. So we're now going to move a little bit more specifically. I am going to lecture specifically with the AIT 160 drive in mind. Keep in mind that I couldn't possibly lecture on all the different types of drives that are out there, different manufacturers, but these are the ones you're going to be working with in the lab. And they are, this is a very simple drive, but it's going to give you an idea of how they work, how it works and how it's controlled, which is primarily the purpose of the second video. Is more about control and parameters and displays and things like that. All drives have parameters and displays. It's just how you navigate the menu. That's really the biggest difference, that and the size of the motor that they're going to be controlling. But I want to, again, talk more specifically about the drive you'll be working with in lab. But again, it applies across the board to all the manufacturers. Okay, so let's go ahead and move into this real quickly. First of all, as I showed you earlier in the first video, you've got two terminal blocks. You've got TB1 and TB2. TB standing for terminal blocks. Okay, and these are basically right here in the drive. Okay, this is TB1 up top, and down below, and TB1 is where we hook our three-phase power. Notice right here, three-phase, and we got three phases are fused. Okay, we've got three fuses going into our L1, 2, and 3. All right, and you got a ground as well. And those are right here on the top, okay? And on the bottom is the TB2, okay? And that's where we're going to hook the three conductors going to the motor. Now, keep in mind, you still have to wire the windings, configure the windings according to low voltage, high voltage, whatever the case may be. That part still doesn't go away, but you just have three conductors coming in and three conductors coming out, okay? And right here in the middle, if you can see it, is TB3. This is where all the controls is going on right here. Okay, this is how we control the drive. All right. So again, you've got it's sometimes called RST or L1, L2, L3, and the terminals for going out to the motor are T1, T2, or T3, which we're familiar with, and sometimes it's U, V, and W as well. Okay, you'll also notice here you've got a DC minus and a DC plus. Well, that came from our DC bus, all right, and that's where we're going to inject DC voltage into the motor for braking. So we've got a couple extra terminals. You don't always use DC for braking. The drive has several options you can use for braking and stopping the motor, but this is your TB1, TB2, and again I showed you the TB3 on the front of the drive. Okay. The drive, this little window right here is our display window. Okay, it gives us this is where we know where we're at as far as entering parameter values and things like that. But it has displays and also parameters. Now, displays are the basically status of the drive and the motor itself. Okay, it gives you information as far as how fast is the motor actually running. It's one thing to command it to run at say 45 hertz. It's another thing to know whether or not the motor is actually running at 45 hertz. Okay, it gives you just a lot of different displays based on of what the motor is doing at the time it's running. And the parameters are the settings. These are the programming. These are the variables that you put in based on how you want the motor to run, how you want it to perform. Also, parameters take into consideration what kind of motor do you have. Is it a 208? Is it 208 volts? Is it 460, 480? What is you have to input the full load amperage value too, because it's going to help protect the motor too. One of the things we talked about in the first video is one of the things that we can eliminate as far as components in our cross the line starter situation like we've dealt with so far. One of the other things it can do is eliminates the heaters or the overload blocks. Okay, you don't have overloads with these anymore because the overload is the current is being monitored in the drive, and when it sees that it's overloaded for a certain period of time, it'll shut the drive off. So we don't need that separate block and that separate interlock contacts with it, you know, overload contacts and things like that. That's all been eliminated. It's all in the drive. So you're now starting to see, man, these drives are the bomb. They really are. Parameters are set up in here, and we're going to step through. We're going to step through some of the more basic and more important parameters. Okay. But first, we're going to talk about displays. When you power up the drive, you'll be able to check the displays 1 through 12. There's about 12 displays, and I know you can't read all this from the screen, but I'll just kind of shout out a couple of them here for you. You got the output frequency. In other words, if you're on display number 01, okay, of 12, it's going to tell you the output frequency, the frequency at which the drive is commanding the motor. Okay, it's also going parameter 02. You can hit the, you can scroll through the display with the up and down arrow keys right here. Okay, the up and down arrow keys will let you scroll from display 1, 2, 3, 4 with your up and down arrow keys. So if we hit our up arrow and went to display number 02, it would tell us the output voltage that the motor is receiving. Remember, the voltage and the hertz have to maintain that ratio, so the voltage is going to vary going out to the motor, all right, based on the frequency. So we can also look at the output current, all right, that's the current going to the motor, and the output power as far as horsepower. It can tell us what our DC bus voltage. Remember, our DC bus voltage is going to be much higher than 1.414, excuse me, times higher than the AC voltage we're putting into the drive. Okay, but it will tell us what the actual voltage is, what frequency we're sending out the motor. Just a lot of information. Right here, number 8 is the heat sink temperature. The heat sink, this is what these metal fins are right here. These metal fins, those IGBTs that we talked about, they're just on the other side of these fins, and they create a lot of heat. With all that firing that's going on, they're creating a lot of heat. So we have an aluminum heat sink that basically draws the heat from the transistors, and then it dissipates into the atmosphere. Now, if the drive is big enough, a lot of times they'll have a fan that blows cool air to dissipate the heat and pull it off of the heat sink, and that in turn keeps the IGBTs cool as well. But you can actually monitor the temperature on this heat sink. Okay, just a lot of cool information, and it's really good information to know. In fact, I had a 400 horsepower drive fail. And I was able to go back in there and see what the heat sink temperature was, and it was a long litany of issues that were going on with not the drive, but actually a system completely separated from the drive. But anyway, a lot of different status information, good stuff. Okay, now parameters. Again, this is depending on what kind of drive you have and the manufacturer, how many parameters they put in. For the Allen Bradley, the parameters start at number 30. Now, we went from 1 to 12 with our display. We skip from 13 to 29. We skip those all together. And our parameters start at 30. And the parameters are the things that we input into the drive to tell it how we want it to perform. We can tell the drive to accelerate. We can tell it to go from 0 to 60 hertz if that's our range. Okay, we can tell it to go to get there in a half a second. I think a half a second is the fastest it can get there. We can drag it out for 30 seconds or even longer. Okay, slowly ramp that motor up to its finally hits full speed. Okay, and we can do the exact same thing with the deceleration. We'd be running full speed, and then when we go to our stop mode, it will slow it down based on how fast we want to slow it down. We can slow it down in a half a second, okay? Or we can drag it out like I said earlier. And the thing about this, we could ramp up in 2 seconds and then decelerate in 15 seconds, however we want to program it, however we want to change the parameters, okay? Another one, a couple other important ones are the minimum frequency. A lot of times, instead of running below a certain frequency, you can set the minimum. Say I wanted that motor to run while we're running in the run mode, I don't want it to run lower than 15 hertz. Okay, we don't want it to run lower than 15 hertz. All we gotta do is set the minimum frequency to 15, done. Okay, so it'll run between 15 and 60 hertz. Maximum frequency is the same way. Suppose I don't want it to run over 30 hertz. Okay, maximum frequency will go from 10, 15, 20 up to 30 and stop. Okay, it won't go over 30. That's based on the inputs that we give it. Okay, and the parameters. So we could theoretically set one to run between 15 and 30 hertz. That's just that band that would run in. Stop mode, how we want to stop this. Do we want to use DC braking? Do we want it to coast? Do we want it to ramp up and down with deceleration? Okay, and we're going to have to tell the drive what type of input voltage we're using, the horsepower of the motor, the overload, full load amperage, things like that. Okay, I do want to tell you one thing about this. Though, when we're talking about deceleration, you'll see this in the lab. If you are driving a rather heavy load, let's say you got a coal conveyor full of belt conveyor full of coal, and we're running it with this motor that's connected to the drive, and you got just a ton of coal, literally. If we try to shut this off too fast, then the momentum of that drive will then turn around and drive the motor. Rather than the motor driving the belt, the momentum of that coal on that belt will then turn around and drive the motor. Well, if we turn that motor, we start driving it rather than letting it do the driving, it actually becomes a generator, okay? And it starts producing a voltage, and that voltage will wind up on our DC bus, and we'll have a DC bus fault. So you got to be careful when we are decelerating. We got to make sure that we are not doing that. I had that happen to me one time. I had a call on a piece of equipment, and it was a big aluminum billet coming down this conveyor, and we had it set to ramp down for like 10 seconds. To take 10 seconds to ramp down. Well, one of the production people talked one of the electricians into ramping it down much faster. In other words, letting it get a lot faster to the end of the process than ramping it down. Tried to ramp down a 20-foot billet of aluminum in about, I think it was like 2 seconds. And what happened is the momentum of that billet came across that conveyor, and then it started driving, actually the momentum started driving the motor, and we started getting DC bus faults. I had to go in and figure out what changed and stuff. And that was just a production guy trying to get more production, get his numbers up and stuff. So, like I said, rarely is anything free. He wound up creating more problems. But anyway, that was just kind of a side story. These are parameters here. One of the ones that you're going to work with, 48 is really important, is this is the type of control that you're going to program into the drive. This is going to be very hard to see, and we're not going to go through all of these. But you can have settings. Number one, I'll read these out to you. This is a 3-wire control. Well, we remember what 3-wire control is. That means we press a button, okay, and then we can walk away from it. It will continue to run because it's got a seal-in circuit. That was with relay logic. All right. Well, with this, it simulates 3-wire control. When it gets the input signal, once it gets it, it'll hang on to it, okay, and it'll continue to run until we hit the stop button. So that's sort of 3-wire. But if we change parameter number 40 to setting number 1, we have 2-wire control, whereas if we're holding the button and then we let it go, the motor will die. The motor will start to shut down, okay? Parameter number 48, the setting number 2, that's the keypad. That's where instead of using push buttons in our control, we're going to control everything with the keypad. We'll start it with the green button, stop it with the red, and once we start it, we can ramp up the speed, ramp down the speed. Okay, that means you've got to be in the cabinet. You've got to be in the cabinet pushing these buttons. Not real practical. Just not a real practical way to control it. But it is an option. That is definitely an option. And again, you got a lot more kinds of control. The parameter 48 is kind of an important one that you'll work with in the lab. Okay, so now when I'm talking about putting push buttons and things like that in place, how does this work? We're going back to TB3. Again, TB3's got 11 terminal points right here, 1 through 11. Okay, and this is where you'll hook your control wires. With a drive, you remember I told you that we eliminated the transformer and the motor starter and the seal-in contacts and things like that. Well, with the drive, it's got its own control. It's got its own control power, and the control power comes out. It's a low voltage. It's about, if I'm not mistaken, about 12 volts on that drive right there. But the voltage comes out of terminal number 7. Okay, the drive produces its own voltage, and it's there poised and waiting on terminal number 7. So we take that voltage, and the first thing we've got to do is we've got to get the voltage from terminal 7 to terminal 8. That is our enable signal, okay? In other words, the drive will not run. It'll power up and it'll light up for you and everything, but it will not run the motor if there is not a circuit between 7 and 8. Now, I think one of the first lab examples lab experiments you're going to work with, you're just going to put a jumper between 7 and 8, okay? But this is typically an E-stop circuit, so that if we hit that E-stop, that drive dies just like that. That's what we want it to do. So we're going to take our power out of terminal number 7, and we're going to put it through this normally closed limit switch, or push button switch, excuse me, this normally closed push button switch. And we've completed a path from our voltage to 8. We've got to have that connection between 7 and 8 for the drive to be enabled, all right? So we're enabled now. So, and again, we're going to have to go into parameter setting 0, parameter 48, setting 0. That's going to give us 3-wire control. So that we're going to take our voltage again, connection point, remember that, and we're also going to have it pass through a normally open push button switch, regular switch, nothing special about a switch going to a drive. You can use them on the trainers that we've had. You've done your wiring projects, okay, just any push button, okay? And what we're going to do is we're going to take that voltage, and as soon as we give a voltage to terminal number 6, from 7 to 6, we're going to press it. We can walk away from it. It'll spring back, but it'll have made contact here with 6, and it's a 3-wire control based on setting 0. So we can walk away from it. It'll maintain it. It'll let it continue to run without us pressing the button. Okay. Same thing with the reverse. We can hit the reverse. The voltage will pass through this switch while we're running in forward. Okay. While we're running forward, and we give it a signal on terminal number 5. It's going to be reversing. So as soon as we're running forward, we hit that. We can just hit it one time and walk away from it. That motor will ramp down. It will decelerate based on the how long we want it to take to decelerate, come to a stop, and then ramp back up in the opposite direction. Okay, and that will be how fast it ramps back up will be based on the acceleration value that we put in our parameters. Okay, you're going to do all this in lab. It's all going to come very clear. But if we have parameter 48 set on setting 0, okay, that's the way that the drive will operate. Again, we've got to have a 7 to 8 connection for it to be enabled. But when we give our signals from 7 to 6, we just have to do a momentary signal, and then it'll go. We can let our button up and go away, and it'll operate just like a ceiling circuit. Okay, same thing with the reverse. Give it a little input signal. It will ramp down, reverse, and continue to run just like a ceiling circuit because it's the 3-wire control. Okay. Same parameter, but if we use setting number 1, this is a 2-wire. Now, if you remember from 1401, the 2-wire did not have a ceiling circuit. So if we are using a momentary and we let it go, then the motor starter would drop back out. Same thing with this. Okay. Again, we have our signal, our control signal coming out of 7. We've got to make that 8. Okay, in order for it to be enabled. And then now, when we give a signal from 7 to 6 through our switch, okay, we hit that momentary and we let it go, it'll start to ramp up, and then as soon as we let it go, it'll shut back off. Okay, so we're on a 2-wire, which parameter 46 is on setting number 1. For the 2-wire, we're going to have to maintain our signal from 7 to 6. The moment we let it go, it's going to go into stop mode. Okay, and that's going to be based on how quickly it stops. Again, it's going to be based on our deceleration setting that we're going to make. Reverse will be the same thing. Okay, we have to stand there and hold this or provide a signal. We could use a selector switch, and that way we could turn the selector switch on and walk away from it, and that switch will maintain the signal. But if we're using a momentary push button, for example, and the minute we let it go, if we're set up on setting number 1, parameter 48, it's going to stop. Okay? Now, I'm not going to go through all the parameters and all the settings. And this one is parameter setting number 2 for parameter 48. And this is the keypad mode. I think if you remember the first video, I told you that you may or may not have to have input switches, press push buttons or selector switches or something like that. We always have to have 7 to 8. No getting around that, okay? But when we're in setting number 2 of parameter 48, if we select setting number 2 for parameter 48, then we're going to be using the keypad to do our control. Like I said, we have to still have our jumper between 7 and 8, okay? And at that point, it says, hey, I'm going to start paying attention. I'm going to get my commands from the keypad. And from that point on, our stop and our start and our speed, all of that, ramping it up and down with our arrow keys, that's going to come into play because we have selected setting 2. All right? There's a lot of different settings. We're not going to go through all of them in the lecture or the lab. We're going to hit the main ones, okay? Another cool thing about these drives, too, is it can take a varying or analog signal to the drive and let it control it based on that signal. This is a symbol for a potentiometer. You guys work with a potentiometer in AIT 1001, basic electricity. It was the knob that varied the resistance, so you had a full voltage going in, and based on how much resistance of the windings of that potentiometer the wiper went across, that varied the voltage drop, okay? Doing the same thing right here, okay? We're having, when you go to parameter 48 and you select the setting for analog input, it will then adjust the speed based on the signal that it's getting. Okay, it comes out of terminal number 1, goes through the wiper of the potentiometer and delivers that varying signal to terminal number 2. And of course, this is the path of completion for the potentiometer. But what we're going to do is, let's say this is this 10 volt DC supply. Okay, what we're going to do is we're going to have 10 volts coming out of here to our supply there, and then we're going to vary it going into 2. So we might put 5, 3, 6, whatever voltage, and we can adjust them. All right, and what the drive sees is going to pay attention to the incoming voltage here on terminal 2, and as we raise and lower that, it's going to raise and lower the speed of the drive, okay? We can scale 0 to 10 volts to 0 to 60 hertz, so that when we are full and we've got our potentiometer turned full one direction, we're getting full 10 volts, that'll give us 60 hertz. If we start turning our knob back and we're dropping from 10, 9, 8, 7, okay, we park it, say 6.5 volts, where it's delivering 6.5 volts to here, well, the frequency is going to come down 60, 50, 40, maybe 45, whatever is scaled to the 6.5 volts. So we can actually vary the speed of that of the drive. Where this comes into play, for those of you who've had 1301 and 1302, the process control, you remember we varied an analog output signal to our valve to maintain a certain level of water. Okay, well, we can use that same signal from the PID loop or the controller, and as it varies the signal based on some other process. For example, let's say we're measuring water in a tank like we did over there, and we need our pump to pump a little bit more water. Perhaps the water level is very low, and we're getting a full 10 volt signal. It's going to drive a pump, filling that tank back up with water at a full 60 hertz. As it approaches, let's say we have to have 12 inches of water. Okay, as it approaches the 10-inch mark right there, the voltage is going to start to drop off a little bit because we can start ramping it off a little bit. And again, as we ramp the pump down, we're saving energy as well. So my point in all that is that we can vary an input signal that will vary an output signal. So the two will work together. So, like I said, the potential for these drives and what you can do with them is just incredible. They're a lot of fun to work with. One other thing too, this is just parameter 45. This is how we're going to stop the motor, okay? This gives us a DC hold voltage, all right? So as we start to ramp down, if we've got DC injection selected, we have the amount of time that we can put the DC injection in the windings to stop it and how long we can hold it there. Just depends on how much time we want to take bringing that motor to a stop using DC injection. Again, it would take days and days to go through all the parameters and understand everything, but this is just the ones that are going to be the most important when you set up a drive. There are much more advanced settings as well, but for this class, again, it's intermediate. We're just kind of introducing drives and kind of getting a feel for them. That's pretty much what we've got, okay? So here's the things that I want you to make sure that you take away, that you have a good understanding, you got your head around, okay? I want to make sure that you understand the three sections of the VFD, how the speed is varied, okay? I'm talking about the processor and how we vary the speed with our frequency. Volts hertz ratio, why we have to maintain that, why it's critical, what happens if we don't, okay? How it's impacting torque. Displays and parameters, kind of just to understand that. And also knowing TB1, 2, and 3 on the drive. TB1 being where we put the three-phase power going in. TB3, the 3 leads going out to the motor, and TB2, and then TB3 is our control, and that the drive itself has its own control voltage that it will use. Okay, so that's basically that's VFDs. Okay, the 2 videos, and then like I said, when you get into the lab, you're going to see how they run. You're going to hear the difference in the way the motor responds. Just a really neat technology. I hope you enjoy it as much as I have. I really like working with these things. But anyway, as usual, if you have any questions or concerns, or if you want to talk to me about that volts hertz ratio, algebraic formula, things like that, whatever it is, come grab me in the lab or at my office, shoot me an email, whatever, and I will be glad to work with you. So I hope you've enjoyed this. It's been a lot of material to cover, but yeah, I know that you're going to be better off once you get out in the workforce for having known all this stuff too. So anyway, take care, and we'll see you in the lab.